So this question is coordinate geometry as a topic, and you're given on your axis this triangle ABC with the coordinates marked, and that's what we're working with. And this is the different parts of the amusement park that Mai's wanting to visit. So the first one, we need to write down the distance between B and C. So if we just mark that on the diagram, B and C is this one along here. And we can see there that the distance, it's actually a vertical line. So the distance is just from here, which is at 0. And it goes up to this point here, which is 20. So therefore we can see that the line is just a distance of 20 meters. And then the second part of the question is to calculate the distance between A and B. So between A and B, we need to form a triangle so that we can find the distance, and then we can use Pythagoras. So we can see in this triangle that we have 4 in this direction, and we have 12 in this direction. So to work that out, I'm just reading off the axis on both of my scales. And therefore the distance of A and B, the hypotenuse, using Pythagoras is 4 squared plus 12 squared. And we need to square root that answer. And that gives me to 3 significant figures, 12.6 meters. So there's 1 mark there for the method and then 1 mark for the answer. So for the next question, it then says that Maya is standing at attraction B and wants to walk directly to attraction A, and we need to work out the bearing of A from B. So if it's of A from B, then we're asked to calculate this angle here, so it's all the way around to this point. So the first thing we need to calculate is the interior angle of the triangle. So to do this, we could draw out the triangle again with the information that we've now got. Let me just draw it out a little bit better. And we can see that the length over here is 12.6. The length over here is 20. We're trying to find this angle. And we know that the length of the other side is also 20. So we could calculate this as well using our triangle. So we have 12 and 16, and 12 squared plus 16 squared, and then square rooted gives me 20. So we can now find that the other side of the triangle is also 20. So I can now use my reverse cosine rule to find the angle. So cosine rule we use when we have 3 sides and 1 angle. So if I rearrange the cosine rule to find this, then I can see I'm looking for it for angle B. This is angle A, angle C, so side A, side C, side B. So if I'm doing it for cosine B, then that equals A squared plus C squared minus B squared, and that's all over 2 times A times C. So if I put my information into my formula, then I have 20 squared plus 12.6 squared minus 20 squared, and that's over 2 times 20 times 12.6. And that gives me an angle where B is 71.639. So 71.639. So I'm just typing that into my calculator and solving it. And you can either type it into nsolve, where you have cos B one side and the equation the other side, or you can just calculate it and then do inverse cos at the end. So that's worth 3 marks. One of the marks is for finding 20 on the other side of the triangle. One of the marks is for using and substituting correctly into the cosine equation. And then the final mark there is for the answer. And therefore we can work out the full bearing. So the bearing of the from B to A is going to be 180, which is this part of the curve here, plus this angle. So 180 plus that, which is going to give me 252. Okay, we know that it needs to be written as 3 significant figures for a bearing, so it's 252. And that there is your final answer. Don't forget to add on the 180 to find the full bearing. Some people just left it as 71.639. So the second part is that a drinking fountain is going to be installed at the point that is equidistant from all the attractions. So that means that it's going to be in the middle of the triangle. If we were to have a perpendicular bisector on each side, it's where they would all meet in the middle. So we need to find the gradient of A to C to start off with. So the gradient of A to C. And we can see here that we go across by 12 and we go down by 16. So 12 and 16. And therefore the gradient, if I do this one here, is change in y, which is the 16, over change in x, which is 12. And that will simplify to 4 over 3. And it's a negative gradient, it's going downhill. So my final answer is minus 4 over 3. Then I need to write down the midpoint of A to C. So the midpoint, and to find the midpoint, I'm finding the middle of 12, which is 6, and then the middle of 16, which is 8. And you can see there that that's my midpoint. So it's just 6, 8. So it's 1 mark for each of those. And then we have marks for the last part of the question, which is to find the coordinates of the drinking fountain. So we need to find at least 2 of the perpendicular bisectors so that we can see where they meet or intersect. So the easiest one to find is going to be the perpendicular bisector on B. Okay, the midpoint is just on line BC, sorry, the midpoint is just 10. It's halfway between B and C, which is 20, so half of it is 10. And because this is a vertical line, this one is going to be a horizontal line, so it's just y is equal to 10. So that's a nice, easy equation to have. Y is equal to 10. So that's the first one, and that's the line of BC. So BC is y is equal to 10, the perpendicular bisector. And then we need to find one of the other perpendicular bisectors. I found the perpendicular bisector of AC, as we've just found the gradient and so on. So perpendicular bisector of AC and for this one we know that we need it in the form of y equals mx plus c. We know that it goes through the midpoint, and we've found this out here. So the midpoint is just 6, 8. So when y is 8, x is 6. And we know that the gradient of the original line is minus 4/3, and therefore the gradient of the perpendicular bisector is going to be 3/4. Okay, so the perpendicular is always the negative reciprocal. And now I can type that into my GDC. You can just type it into NSolve and find what C is equal to, and C is 3.5. In which case we know that the equation of the perpendicular bisector for AC is y is equal to 3/4 of x plus 3.5. So I now have my 2 equations of 2 of the perpendicular bisectors. So I've found the equation shown here, and then we also have the equation, the gradient is 3/4. So we also have the gradient of this one here, so something like this, and then we can see where they intersect. So to find where they intersect, we need to make them equal to each other. So we have y is equal to 10 and y is equal to 3/4 of x plus 3.5. Now on your TI-84, you can either plot them and then find the intersection, or you can do simultaneous equations. It's up to you, whichever method you prefer. But either way, you should find that the point of intersection is 8.67, 10. So it meets that x is 8.67 and y is equal to 10. And they're both just three significant figures or fully accurate. So you also get a mark for each part x and y of finding the intersection there at the end.